Hi Matt, we talked about infrastructure and scalability previously, but what are the implications from a data science point of view, particularly from that early adoption?
Yeah, sure. So the best way of describing it is sort of like data science day one. So in the data science day one world, you're normally operating with a small number of experiments. And what that means is that you can, almost when I do sort of small scale data science experiments, I might keep track of some notes in my notepad, and I need to record things called hyperparameters, which are, effective ways of making the model operate. I've got a very small infrastructure that I'm working with, and I'm fairly self-contained. So because I can dice and splice my data however I want to because it's quite small, and I can manage my own infrastructure because there's only me using it. My own data science environments I have a tendency to build myself. I can break them. That doesn't impact anybody else, but it does mean that I'm sort of quite constrained when it comes to some of the things that I can achieve. But it allows me to run experiments quite quickly, so iterate through and try and isolate some of the models that are going to be most effective for the types of problems that I'm tackling.
And how does that compare to what you might call day two, or the next stage as you look to scale out from the data science perspective?
Yeah, definitely. So data science day one environments are not designed for scale. As soon as I want to have multiple data scientists working on, a specific problem, so I might have zeroed in to the types of techniques that are going to be successful. Once I've done that, well, I need to start thinking about how do I have multiple people working with multiple AI frameworks? How do I share GPU resources across all of those people that are working with it? What happens when I want to run an AI build in parallel? How do I now start to tune the hyperparameters that are associated with these models? These are much bigger problems. And as a result, I'm normally working with significantly large data sets. So if I were to try and do that with my little small environment, the chances of it working is going to be very low. I'm going to be talking about waiting for significant periods of time. When I start to move into a much larger collaborative environment, there are a whole different set of logistical challenges. However, I now have the compute grunt that I need to execute my model construction much more effectively.
And I've heard you talk about an analogy that you use for day one and day two. Would you mind sharing that with us?
Yeah, sure. So let's say, for example, David, well done. You're a data scientist now, and your boss comes up to you and says, "David, I've got 2 decks of cards. They've been very, very well shuffled together. What I want you to do is to write an algorithm that takes these 2 decks of cards, puts them back into their original deck in numerical order by suit." And you can build an algorithm for that. You could build an algorithm. You'd probably make notes on a pen and paper as to how you were going to achieve this particular problem. But of course, as we know, bosses are never quite so simple with their ask. So when you go back to your boss and say, "I have got the best algorithm for tackling this problem," and he says, "Awesome. Come with me, David." And he takes you across the road and he opens up the doors of a warehouse, and in it are thousands and thousands of decks of cards. They've all been heavily shuffled together. And he says, "Take that algorithm that you've got and apply it to that problem."
I see.
So, but let's say you've got loads of croupier mates, loads of friends who are capable of working with cards, So you get all of your croupier friends together and you say, "Right, okay, I've got this algorithm that I can apply to this bigger problem." But that creates a whole different set of logistical challenges. How many cards do I give to each croupier? What happens when one croupier has got a card that another croupier needs? Suddenly, the problem becomes much more about logistical management and less about the algorithm. So in that analogy, what I've got is the cards represent the data. The algorithm that you've defined represents your AI approach, and the croupiers represent your compute infrastructure. So you can see it becomes less about management of the individual workings of the model, but much more about how I run the construction of that model in parallel. And that's how the data science day one problems differ from a scale perspective against data science day two.
Good analogy. Yeah, I think it explains it really nicely.
Yeah.
And you mentioned obviously there's multiple people there involved, and we've spoken about Team AI. What does that Team AI consist of? Can you expand on that for us just a little bit?
Yeah, definitely. So I think we've got two aspects when I think about Team AI. One is at an organizational level, which we've talked about in terms of ecosystem. But secondly, when it comes to who do you need to build, to do this model building? And there is a bit of a misconception that data scientists do everything. Mm-hmm. And there is the concept of a full stack data scientist, which is somebody who has a breadth of skills across the portfolio. But in most cases, you're going to be more successful if you build a team of people with individual specializations. So you do need people, data engineers, who can gather the data and do some initial cleansing of it to get it ready for data scientists to perform the model construction. Because data scientists need to take the data and put it into a format that they can put into their AIs. You can't just take raw data and put it into an AI. That doesn't work. It needs to be transformed into such a way that allows you to do model construction. But data scientists are not developers. So you do need machine learning developers who can take the statistical techniques that a data scientist is using against the data and then construct code associated with it. You also need people who can build the end-to-end life cycle. So when it comes to how you build your AI models, you're going to want to do it in a repeatable fashion. So when you get more data in, you don't have to manually go through the process. You want that to happen in an automated way. And that's with machine learning ops, ML ops, which we've talked about before.
Yep.
So you need people who can understand how the ML ops capabilities work. You also need people who understand how to plug together all of the infrastructure and the open source components, assuming you've gone down the open source route, together that are going to make it successful. When I start thinking about how to broaden the team out, you also need people who have got an understanding of ethics and compliance. Mm-hmm. You need people who understand how to run things through governance processes, because you do need to expand some of your existing ethics regimes and governance processes to make your ability to deploy AI integrate into your existing business processes. So it is about building the broader team together, including the operational side, because you're going to want to monitor your models. More than just from an infrastructure perspective, models can drift. So if the data that they're operating against changes, you need to change the model. For example, let's say you launch a new product, common thing for customers to want to do. Yep. If you haven't trained the model on that new product, it doesn't know about it. So as a result, if you deploy a new product into your production setting, your AI will drift. So it will become less accurate, and you need to look for these things. So you need to be talking about how you upskill your operational staff to understand when the models that are in production are starting to drift. So there's a lot of people that you need to be involved in team AI that is going to make it successful.
And then overlaid with right cultural approach and governance as well.
Yes.
Like giving the whole picture, yeah. So.
And would you say that would all need to be internal, or are we going back to the partnerships and actually utilising the ecosystem of resources, internal, external, to make sure that you've got all of that covered?
Definitely. I think you can span that with the ecosystem, definitely.
Yep.
I do think you need some internal capability, because if you're going to take AI seriously, you need to have some understandings. This is from a customer's perspective, this is their data. They're the people who have the best depth of understanding of their data. So that's where some core skills need to come in. When it comes to model construction, again, you don't want to have, don't let an organization do AI to you. You need to have enough skill to understand what data you're using, what models have been applied, and the outcomes that those models are driving, from a regulatory perspective, or if you want to change things. But you can definitely augment and provide additional capability by leveraging the ecosystem. and making the absolute most out of partnerships to come in and provide that end-to-end story. I'm a huge believer in any organisation that says they can do end-to-end, top-to-bottom artificial intelligence is just not paying attention. It's such a fast-moving discipline. The only way to be successful is by leveraging your ecosystem as much as possible.
So AI is a team sport.
Definitely. Have I said that before?
It is.
Right, look forward to our next
Finish
session.
on. Thank
Okay,
you.
thanks.
Thank you.